Today we're going to talk about square roots. In the last lesson we talked about exponents. Square roots, basically the opposite of that. Here's some vocabulary. I would like for you to pause the video at this time, write these words down, and then as you go through the video, make sure that you have a good understanding of all of these. Okay? When you multiply a number by itself, you get a square. Okay? The number that you multiplied is considered the square root of that answer. So basically we use this symbol right here. We call that a radical symbol. When you see just a radical symbol like this, there's an understood 2 right here, so it is square root. But radicals are also used for other things. For instance, you could have a cube root, which basically is saying what number cubed gives you what's underneath here. That little number is the inverse of your exponents, and it's called an index. Okay? All right? As long as you don't have a negative number underneath here, you should be able to find a square root or at least get close to that. Okay? And as long as what's underneath here is not negative, then the square root and the square cancel each other out. For right now, if I were to walk into the room and ask you what is the square root of 36, I would expect your response to be 6. That is the positive root. That is called the principal root. Okay? Now, as soon as you put a variable in there, so if I gave you a problem that said x squared is equal to 36, you take on added responsibility. At that point, you have to give all possible roots. So every number that you can take a square root of has a principal root, which is the positive root, and a negative root. So in this case, you would have to tell me that x is equal to positive or negative 6. You have to put down both. You don't get to choose. You have to put down both. Now, the rationale for that is if you take a 6 and you square it, you get 36. If you take a negative 6, and you'll notice that I put it in parentheses right away, if you take a negative 6 and square it, you get 36. So you have to use both. We use this little plus and minus symbol in front of the radical sign to represent positive and negative. Here's a little example showing you that both the positive root and the negative root are going to give you the same answer. Okay? Because 4 times 4 is 16, and negative 4 times negative 4 is 16. So therefore, the square root of 16 is 4. That's the positive root or the principal root. And then the opposite of that would be negative 4. Okay? Perfect squares. Here's a list of perfect squares. Now, you should know these. You actually should know more than these. So you should know what 11 squared is, 12 squared, 13 squared, at least up through 13 squared. If not, 14, 15. You should probably know what 20 squared is, 30 squared, 40 squared, 50 squared, 60 squared, etc. Okay? So look at these. Now, this is what I mean by a perfect square. 0 squared is 0. We're not using that one hardly ever. 1 squared is 1. We really don't use that, but we need to know that it's a perfect square because if I ask you for the square root of it, you need to know that it's 1. Okay? 2 squared is 4, etc. down the list. You should know these by heart. Okay? We talked about this. The small little number up here is called the index, and that tells you, for instance, if it's a 4 up there, I'm asking you what number to the 4th power will give you the value that is underneath here. So here's an example of that. The 4th root of 16 is 2. There's some extra terminology that goes on there, like when we say a number raised to the 2nd power is squared, a number raised to the 3rd power is cubed. So therefore, we take the cube root, we take the square root, we take the 4th root, and you can use anything that you want. Okay? So let's just make sure we know those. All right, so here are some examples. This radical sign, since there is no index there, means that there's a 2. So what this is asking you is what number squared will give you 81. And in that case, it is a 9. Okay? All right. This next one also, that's an understood 2 there. So this is saying the opposite of what number squared will give you 25. So that's letting you know, by them putting that there, that's letting you know that they want the negative root of this. So the square, what number squared will give you 25 is 5, and since they want the negative root, they told you that right there, it's negative 5. Now, when you have an index that's not 2, if your index is odd, and the number underneath there is odd, if your index is odd and the number underneath there is a negative, that tells you right away your answer is going to be negative. So what number, this is saying what number cubed gives you 216? And that's going to be 6. And again, since this is negative and this is odd, my answer is negative. All right, this one is asking you what number to the 4th power is going to give you 81, and that's going to be 3. Here, I just split it up. This is a square, this index of 2 there. So this is basically saying the square root of 49 on the top and the square root of 9 on the bottom. What is the square root of 49? 7. And what is the square root of 9? 3. Okay? So sometimes they ask you for the square root of a number that is not a perfect square. Example here is 15. It's not a perfect square. It's not. So what you need to do is we need to go back. We can either on our calculator hit square root 15, hit enter, and this is what we get. This number is an irrational number. It does not have a specific end. It does not terminate. It does not repeat. Okay? What we can do, though, is we can use other perfect squares to kind of get an idea. So, for instance, the square root of 13, there isn't one. So we know that the square root of 13 is somewhere between the perfect squares. So 13 is somewhere between the perfect squares 9 and 16. And the square root of 9 is 3, and the square root of 16 is 4. So that means the square root of 13 is somewhere in between here. So you can kind of look at it and say, okay, is 13 closer to 16 or closer to 9? It's pretty much in the middle there. So my first guess is going to be 3.5. So I take 3.5 and square it, and I get 12.25. So I know that that's definitely too low. So then I'm going to go up one, 3.6, and square that. That's still too low. So I could go up to 3.7 and square that, and it's too high. I could back it down to 3.65. So basically you're doing a guessing game back and forth to kind of get where it is. Okay? When we do this, when we either do it on our calculator or when we approximate it, we use this symbol right here. And that means that it's not exactly equal to, it's approximately equal to. All right? Numbers can also be classified according to their characteristics. We've talked about this before. Your natural numbers are your counting numbers, 1, 2, 3. Add a 0 to that, you have your whole numbers. Integers are the whole numbers and their opposites, so that's -1, -2, -3. And a rational number is any number that can be written in the form a over b. I like to say it's any number that can be written as a fraction. Okay? B cannot equal 0 because having a 0 on the bottom of a fraction is undefined. Okay? Things that are rational numbers would be, of course, anything that can be written as a fraction, your terminating decimals, your repeating decimals, because those can both be written as a fraction. Terminating decimals you write as a fraction by putting over their place value, and a repeating decimal, I can show you how to do that later. Okay? Those are your rational numbers. Now, very quickly, we use an N to represent the natural numbers. We use a W to represent whole numbers. We use a Z to represent integers, and I'll tell you why in a minute. And we use a Q to represent rational numbers because every rational number can be written as a fraction, which is division, which is a quotient. Okay? Irrational numbers are all the numbers that cannot be written as fractions, and we use an I for that. That's how come we can't use that for integers. Okay? So it's telling you on here that that decimals are either terminating or repeating or non-terminating, non-repeating. If they're non-terminating, non-repeating, that means it's irrational. If it's any whole number that you're trying to take a square root of and it's not a perfect square, it's an irrational number. Put all of these together, and you have the set of real numbers. So real numbers are made up of rational and irrational numbers. Here they are right here. Rational and irrational numbers. You'll see here's your natural numbers. Add a 0 to that, your whole numbers. Add your negatives. There you got your integers. Add all your fractions and decimals. So everything that's written as a fraction, everything that is a terminating, which would be like this, 4.5, or repeating decimal. Okay, now, how do we classify those? Okay, negative 32. What I want you to do is I want you to find the smallest group that it fits into, the one closest to the center. It's not a natural number, it's not a whole number, but it is an integer. That means it is part of integers, rational numbers, and real numbers. Okay? The negative square root of 14. Well, first of all, 14 is a whole number that does not have, it's not a perfect square, so that automatically puts it over here in the irrational numbers. Regardless, positive, negative, whatever, it's over here. Okay? 7 and 4/9, that's already written as a fraction, isn't it? So the smallest group, it's not a natural number, it's not a whole number, it's not an integer, so it is a rational number, which is also a real number. Square root of 100. Well, I need to simplify this. What is the square root of 100? It is 10. Is 10 a natural number? Yes. It is right in here. That means it is a natural number, a whole number, an integer, a rational number, and a real number. So that's how we classify those. And that's it.